I'm the founder and CEO at Ethyca, and we've been working on a project called FIDA, which is what I'd like to take you through today. So it's a theory about how you can approach privacy ex-ante, so that is to say, before the problems start to happen. So what we'll go through today is sort of a view that we have on privacy and the problems that exist, particularly for large commercial businesses, and how we might start to address those. Explain to you a little bit about what FIDA is and how it tackles those problems, the benefits of this sort of privacy as code approach, if you will, and then show you two real-world examples, so try and bring to life what the tools can do today and what we're trying to build with FIDA in the future. So very quickly, the challenge of privacy or trust in privacy in software development, or at least the way we see it at Ethyca, I think we'll probably all agree on this, right? Privacy should be a feature of every technology system, right? It shouldn't be something you add on after the fact or you think about afterwards. It should just be innate. But it's not, right? For many, many reasons, it's not. For developers in particular, it tends to manifest as a lot of friction and complexity. It isn't because developers don't care or engineers don't care. It's because it's not, for many of them, other than those that are in this room and the specialists that focus on privacy engineering, for many, it's just not part of their core tasks, their objectives, the tickets they tackle, the jobs they have to do. And often it manifests as the legal team sort of downward pressure to think about compliance, right? And compliance feels like a pretty unpleasant thing to think about when you're trying to move quickly. And the way that we think about privacy when we were trying to tackle this problem is to look at the software development lifecycle, right? The virtuous cycle we all know, right? You ostensibly design something, you eventually implement it, you hopefully test it really rigorously, and eventually you'll deploy it. And if you think about this in the venture-backed world that we live in today, the goal tends to be to sort of deliver a minimum viable product, right? Something that you can prove works quickly. So you're iterating really fast. You're probably not thinking deeply about privacy and security, or there are a handful that are, but not everybody, unfortunately. And the moment happens when you deploy a product. Hopefully it grows, right? It scales, so you get customers or users of your system. That's the goal of any of these systems. And typically, that's the point at which most very early businesses or products start to think about the risk of privacy, right? It's ex post. You've deployed the product, the horse is proverbially bolted, and now you've accumulated lots of sensitive data that has real risks associated with it. And you start to think about those problems. And for many organizations, not the most sophisticated in the world, this is where they'll start to think about it from a compliance perspective, right? We need to comply with the GDPR or the CPRA or CCPA or the LGPD. And so we need to know what data we have. We need to understand the regulations we want to enforce. And so we start to spelunk in data and infrastructure, right? It becomes this sort of deep dive into our systems. The challenge when you think about this is it's effectively ex-post governance, right? Like it's effectively trying to impose governance on a system that has already been built. You know some things about it, but it's evolving really rapidly. It's very difficult to govern. And a really good example of this, most businesses struggle with effectively inventory management, right? Identifying the type of data they have. What exists across their distributed systems, and as they've grown, they've got sort of orphan data sets and systems that aren't fully documented very often. And instead of asking ourselves, why is that happening? So why are we spelunking in data infrastructure, as folks here like to say? We need to look at how that happened. What happened upstream that caused that? And it's design and development decisions that weren't adequately documented, annotations that weren't provided in the software development lifecycle that mean that we don't understand what's in our data systems over a decade or 2 decades. And therefore, it's very difficult to govern, right? We don't have the context necessary to control those systems. And so the question we've been asking ourselves is, how could we insert governance? And that sounds like an unpleasant word, but it's really powerful. How could we think about applying, essentially, promises to our systems when we're building them, right? Like, how can we assure that the things we promise to our users will be the only things that our system will do? So how can we govern them earlier? And so that's what we've been thinking about mostly as we've been building FIDA. A more concrete sort of manifestation of that then is, well, how do you bring that to life for developers, right? For developers today, you're thinking about your tech stack, maybe front end, back end, database, version control systems, probably some kind of infrastructure as code to deploy into the cloud. And then the sort of privacy and governance function happens asynchronously very often, right? A lot of documentation, form filling, privacy reviewing. And what if you could provide tools to developers so that they could adequately describe their systems, such that you could then govern them. So you could create a layer of governance as code or privacy as code. This would ease the bar of entry for developers, right? Make every developer ostensibly some level of a privacy expert or engineer. They don't necessarily understand the regulations, but they can describe their systems such that we can start to think about how we govern them or enforce them. And it would make the GRC function, the team of the GRC function, more well-oiled and more tightly integrated with that development process. And so the hope with an open source standard for privacy as code is that we could start to solve this. And that's the work that we've been doing and what I'd like to share with you today. So the starting point for this is, what is FIDES? So first of all, FIDES is named after the Roman goddess of trust. And we think it's an apt name for the project. It's something we've been working on for almost 3 years. It's an open source description language that allows you to describe privacy behaviors and characteristics of systems, if you will. You could also abstract that and say it allows you to describe data such that you can govern it not just for privacy. So it's a lightweight description language and a set of tools that sit on top of that language that allow you to perform certain functions both in the CI pipeline, so the code management environment, and then in the runtime environment. And our hope is to continue augmenting the capabilities of both the language and the tools to provide more robust governance tooling and support for organizations of various sizes. So what are the benefits today in the current GA of FIDES? Well, it's a very developer-friendly language, and I'll show you that in a moment in a demonstration. So rather like Terraform describes infrastructure, this can describe privacy resources and characteristics. Very easy to understand, very easy to read, pretty easy to implement very quickly. So a low bar of entry for most developers. It integrates directly into your projects, so that is in your CI pipeline and your Git projects, so you manage privacy metadata in your Git projects. So they're effectively, you're now describing your systems at source rather than post-deployment. And because you can do that, you can start to evaluate policies in your CI pipeline. So you can start to enforce decisions or trustable criteria or sort of risk mitigations when you're shipping code. And finally, because you've got a metadata layer, right, if you're describing your systems concretely as you deploy them, you now can really understand the information that's flowing across distributed systems. You can enforce runtime policies, right, the ability to retrieve data for a user under the GDPR or potentially erase it. And erasure is obviously a tricky topic in terms of the definition. We believe at Ethyca, like I hope everybody here, that you should just delete the data. Not every business thinks the same way, and you need to provide capabilities for how you might manage that. So just to sort of orient you very quickly on the tools that are available, there's the language, which I'll walk you through in a moment, called FIDES Lang. And we'll explain the details of that. There's then the FIDES control tools. So think of those as tools that run in the software development lifecycle. So in the CI pipeline, there's a server and a CLI tool. They comprise sort of the components of the control tools. And that allows you to manage policies that you want to enforce in your CI pipeline and store the metadata that's generated from the annotations that occur in your code base. And then there's FIDES Ops, or the operations tool. So that's a containerized application. It's a Docker image. You can deploy that in your runtime environment, connect it to various data infrastructure, and write policies or rules to enforce in that. So again, erasure or de-identification, if you will, or retrieval of specific categories of data, for example. So the first thing I'm going to do is explain the taxonomy and the language today and where it stands and what we hope to do with it in the future. This is a little hard to see, so I'm going to jump out of this document. And hopefully, where we start to demo things, this won't start to break. So this is, let's see if we can make this a little bit bigger. This is the open source documentation, so I'll post links to this in the Slack channels afterwards if anyone wants to read it. But this is just an explorer of the taxonomy. So just to explain the sort of primitives that are available to describe things, the taxonomy was designed to support or synthesize or translate, if you will, the GDPR, the CCPA, or the CPRA now, the LGPD, and it also supports standards like ISO 19944, so which is used to describe cloud service providers, right? And the intention of this is to provide a very simple abstraction for developers to quickly annotate or describe their systems without having to understand the underlying laws or regulations, right? That's not the job of the developer per se, but they do understand what their system is doing. So the first component of the taxonomy is the categories. So think of the categories as the what, right? The type of data that you're handling, right? It could be user, derived, or provided data, right? The distinction being quite clear there. It's provided by the user directly or derived about the user through observation, perhaps. It can be identifiable or non-identifiable. And then there are many sort of levels of subcategories that describe the particular groupings of information, such as contact data, account information, et cetera. Now, one point I should have made is that this is the taxonomy that FIDES ships with. You can actually extend this endlessly, and a lot of our design partners do to support their specific needs. Or you can rip it out and replace it with your own taxonomy if you wish. The goal, however, is that we arrive at a standard. Actually, our hope is that we have a standard taxonomy because that encourages interoperability between systems and service providers, right? So the first part is the categories. The second are the data uses. And the data uses describe the how, right? Or how you're using that data, for what purpose, right? It could be third-party personalized advertising, a very unpleasant thought. It could be optimizing something in the system, for example. Then data subjects is exactly what it sounds like. It's the individuals of whom are in your system. Could be a user, customer, consumer, a patient, etc. And then data qualifiers is a little hard to see in the visualization tool, but it's essentially a spectrum of the degree of identifiability that a data set represents, from fully identified information, right, quite specific personal data, through to truly anonymous information, or potentially variants in the middle, like aggregated data, or pseudonymized and unlinked, or pseudonymized. So those are just the basic sort of primitives of the taxonomy that are worth understanding. So from here, I'm going to dive back into the document and sort of walk you through the benefits. It should be self-evident, right? But with a very simple language, any developer can quickly declare what their code base is doing. That could be at the sort of abstract level, so it could be a feature owner or product owner, or it could be individual developers describing what their code is doing, so the purpose it's serving, and what data it's acting on, so the inputs and outputs of information. You can then evaluate that. So you can look at that against organizational policies in your CI pipeline, and you can enforce against it, right? We can say, we don't use these types of behavior data and location data together, so we can't build services or deploy services that are going to do those things. That creates an unnecessary risk for us as an organization. And you can audit that. And because you're creating this cycle of evaluation, you're generating a metadata layer that's both at the application level, so individual services or applications, and also the data sets or infrastructure that's storing information. So you get a very strong visibility of the sort of lineage and flow of information, such that you can govern on top of it. So it allows you to start to risk mitigate in the software development lifecycle, not completely kill it, but certainly mitigate it heavily. It allows you to generate an audit trail of the decisions you're making in the software development lifecycle. And if you think about Facebook's consent decree with the FTC, it's a prime example of how we're being asked as developers, particularly in large organizations, to start to demonstrate that, right, the decision-making that we take as we build things. And it provides a consistent data inventory, right, from the moment you write code or modify a data set. And because of that, you've essentially got context, right? You understand what your systems are doing and how. Therefore, you can govern on top of them. And so then we pass to tools that can actually allow us to actively govern on top of that. So with that, I'm going to get to two real-world examples. These are very simple. The first of these is actually enforcing a policy in our software development lifecycle. And we'll get to the second one, which is actually executing a subject rights request, for example, under the GDPR to retrieve a user's data. So let's start with enforcing policies. So this is taken from the CNIL, which is the data regulator in France. This is their proposed recommendation for how you conduct a privacy impact assessment. You might know them as privacy reviews also, right? Very, very important to do, right? It's the evaluation of the risk related to how we're using information or building systems. It's one part of the sort of principles of privacy by design. The challenge in practice, however, is that it's often a very labor-intensive process. Engineers are undereducated in how to conduct it, and it requires real expertise in privacy engineering to do it very, very well. Now, we can't remove all of this, but we could certainly streamline this, right, by providing tooling that starts to attempt to evaluate and mitigate some of the risks related to how we use data. So if we could move away from this sort of very complex Rube Goldberg-like machine to evaluate what we're doing in our systems and whether they pass muster, we could arrive at something much more powerful. And so just to explain the tooling and the sort of layers of how it's used operationally, the left side of this is the code management environment, right? So the software development environment. And the right side is the runtime. So right now we're focused on the left, and you'll see FIDA's control sits beneath that. So the control tools are used in the software development lifecycle. Again, there's a server and a CLI tool. And if we think of the sort of layers of an organization, the top layer is the governance, right? Sort of executive decision-making about what we can do as a business. So policies we permit, policies we reject, things we allow ourselves to do internally or externally as a result of regulations. And then there's feature and product owners, right? The folks that build things, right? So they're responsible for essentially what something might do or how it might act. And then finally, you've got engineers who are actually building, right? They're designing, technical design, implementation, eventually deployment. So what this allows us to do here is essentially write policies at the upper level. It allows feature and product owners to describe what we're doing with our data, so its use, its purpose in our systems, and allows engineers to quickly describe or declare the types of data they're using to achieve that purpose. So between these three, we effectively have policies we can enforce, a description of how we're using that information, and then the types of data that we want to use. So to bring this to life, I've got a local demo environment running here. So this is all local to my computer, I should say. So one point of distinction is typically the FIDA's control server runs for a group of engineers, right, as part of your CI pipeline. So in this demonstration, it's not part of the CI pipeline. It's running locally. Therefore, I have access to both the policies and the declarations. That would be obviously a security no-no. Ideally, these would be clearly segregated. But for the purpose of demonstration, I have both. So just to explain what we've got, I've got a fictional e-commerce system running locally here. So let me just, hopefully everybody can see that. I'll zoom in a little bit more maybe. Okay, so we've got a couple of documents open, which I'll walk you through in a moment. But just so you can see what's running in my browser, I've got this Flask application running. It's a very primitive e-commerce website. It's nothing special, right? It's a Flask application, simple Postgres database, and a couple of tables, right? There's a products table, a users table, and a few other things. And so, for example, I can log into this, right, with a fictional user. And then I can purchase a product. So I'm going to purchase something. I'm going to put in my address. And I'm going to purchase. Now, there's no checkout flow per se. We've no credit cards. It's just a simple data capture, right? So we've selected a product. We've got an account. We have a password. It's got some of our personal information. It's got our delivery address. Those things have been collected in Postgres. And if we scale that into a large business, that's probably flowed into several warehouses, some sort of data residency systems, and a bunch of third-party providers, probably. So from here now that we understand the basic system that we're operating, we're going to look at how we would evaluate a policy. So in order to understand that, I'm just going to show you a few of the documents we have open here. The first you'll see is a dataset declaration file. So it's a YAML file, so everything you declare with FIDA is in YAML. It's very simple to write and both to write and to read. You'll see here that there are essentially three tables: products, purchases, and users. So if I expand this out, I've got some products here. But we'll go to the users table for a moment. So this here is a declaration of essentially the fields that exist in this very primitive table, right? We've got a created at field, email address, first name, ID, and last name. So if I expand out created at, we can, So if I expand out the created at field, we can see there's a data category assigned to this. So the created at timestamp is essentially data used for systems operations. It's not, in this instance, not particularly interesting. Conversely, we've got email address here. And this is declared as a data category of user provided, identifiable contact information, or contact email, you can see here. Now, we can make a declaration at any level of the taxonomy, right? So if we wanted to as an engineer, we might not understand what type of data it is precisely, but we know it's user provided and identifies them. So we can coarsely declare the type of information we're handling. That, of course, means we can only enforce policies that coarsely. So ideally, we're fine-grained annotations where possible. So we can declare each of these very simply. It can be an object with multiple labels, and we can add labels over time. We've declared these in a single dataset YAML file for that Postgres database. And separately, we have one that describes our e-commerce system. Now, this is a very simple system, and so we've got a single annotation file. You could have annotations that describe individual services or components of a system, depending on how granular you want to enforce things. So you can see here in this case, it simply describes what the system is. It's an e-commerce system. And then we have the data categories that we're operating on. So we can see here there's user-provided identifiable data. There's user-derived identifiable data. There's user-identifiable data and system operations data. And the data use, so what this system is doing with data, its purpose is just providing systems operations. It's not particularly interesting. And then there's the subject type. It's customer data. So it's a very simple declaration. So now imagine for a moment that I'm an enterprising engineer working at this company. I need to add Google Analytics to it. I've decided that would be really helpful. Now, as is common, most developers don't know that Google Analytics collects personal data, or there's confusion over IP addresses being personal data. And so I've declared here that I've added Google Analytics. And I'll just expand this one out. We can see here I've declared that I'm collecting IP addresses, some location data, some identifiable data. And so what I'm going to do now, although we're not running a CI pipeline here, I'm just going to run an evaluation quickly against our policies. So basically, it's just bringing up the FIDA servers. It's going to collect the available policies. It's going to collect the metadata that's available in all of the annotations in the project, and it's going to evaluate those against those policies. And you can see here we've had a failure. And so the failure in this case is that we are not permitted to use personal data for these purposes. So I've got an error message here. Now, I can very quickly look at this and show you the policy. So we've got a policy file here that describes a very, very simple rejection policy. In this case, it rejects the use of sensitive data. And as we can see here, it's specific categories of sensitive data. So we cannot use any of these types of data for any of these uses, for either improving personalization, advertising, third-party sharing, or training AI systems. We've sort of declared a very simple set of conditions here. It rejects this check-in. Now, okay, as a developer, I go and read some documentation about Google's analytics engine, I realized that I can anonymize the IP address, so effectively pseudonymizing the data that's risky. So I'm going to redeclare this now as pseudonymized data. That's a very simple example. And we're going to run our evaluation again. So we've essentially updated some of our code base, redeclared our evaluation, and it has passed because it meets the organization's criteria. And each of these is logged as part of an audit trail, so we can evidence the decisions being made by the developer against the declarations they've made. I'm very conscious I've run out of time and I've got another example, so I'll rush this last one very quickly.
Speak faster.
Don't speak faster, slow down. Okay, apologies. Okay, no problem. With that, we've shown a very simple example of evaluating a policy in the CI pipeline. The other side of this is the ability to enforce with that metadata layer operational tasks, like the ability to retrieve a user's data. So I'll do this very quickly. So in this case, what a privacy request normally looks like under the GDPR might be like this: a document received by an organization making a request for access to data or erasure, for example. What it normally looks like as a process for an organization is a giant Rube Goldberg machine, right? Retrieve data, create tickets, identify where that information is, and return it to the user. Now, with these tools, because we have a consistent metadata layer, we can write a policy for requests, and we can execute those against known identifiers, like specific keys, for example. So in this case, I'm going to run one very, very quickly. So I'm going to just retrieve some data. So we're going to run a ops request. And you'll see here that it's allowing me to set a target from the taxonomy for the type of information I'd like to collect. So, for example, I could say, I specifically want to look at user data, for example. So all of the data under user, or I might just want to look at contact information, for example. So I'm going to construct a policy that retrieves everything about our user in the e-commerce system. So we'll just use the primary user resource. It's an access request in this case. And we're going to put in our user's email address. And so we can see, typical, don't demo live. We've had a failure. There we go. So we can see the JSON object that is returned is all of the data related to this user based on the annotations in that data set. So if that database is modified in any way in the future, that policy can be enforced consistently against that or any number of systems. So for example, if we wanted to change the request, we could say, well, we're going to run it only on one specific type of data. So we're going to say user provided identifiable name. Provide their email address. And I've typed it again, apologies. Okay. And there we go. It's only returning the name for the user in this very simple example. But you can construct very complex policies for both erasure and retrieval. I'm so far over time, I'm going to just skip to the end and say that essentially the project is completely open source after 2.5 years of work. And our goal is to simply encourage those to contribute, comment, assist us in refining the taxonomy, and improving these tools so they can lower the bar for every engineer to improve the quality of privacy in their systems. Thank you.